In this lesson, we discuss trigonometric integrals. There are different kinds of trigonometric integrals, but the one that we are interested in this lesson is about the integrals which look like of the form the integral of sine to some power m of x, or in more general situation kx, times cosine to the power of n kx dx. So sine m, or sine to the power of m of kx, times cosine to the power of n kx. So these are the type of integrals that we'll discuss in this lesson. So in this lesson, we discuss integrals of the form, this form. To make it more understandable, I divide this into four cases. Although the first three cases are kind of similar to each other, and we have already discussed, in fact, and you have seen that in Calc 1, because that's by some substitution that you have seen in Calc 1. And this is, so the first three cases, which are, as I mentioned, similar, are not really new. The fourth case is relatively new that we will do, and but to be comprehensive, I'll mention all of them. So there are four cases. As you will see, the first three cases are kind of similar to each other. So case one. Case one is the case that the power of m is even and the power of n is odd. So we make cases based on m and n being even or odd. So case one is the case that m is even and n is an odd number. So m is an even integer and n is an odd integer. For example, suppose you want to do sine to the power of 8x cosine to the power of 3x dx. So what substitution do you suggest? In this situation that power of sine is even and power of cosine is odd, we let u be sine x. This works for all the integrals that are under case one, that the power of m is an even integer and the power n is an odd integer. So we let u be sine x. The derivative of u with respect to x is cosine x, right? Which means that du is cos x dx. So we use this substitution to solve the problem. So let's see. Let me go to the next page. So the integral was sine to the power of 8x cosine to the power of 3x dx. U is sine x, so this simply becomes u to the power of 8. Du is cos x dx. Du is cos x dx. I see that I have cos cubed x dx. I separate one cos from that and write it next to dx. So cos x dx is in fact du. But from cos cubed, I separated one cos, so cos squared remains there. So far I have been able to write this part in terms of u and this part in terms of du. How about cos squared? That's something we use trigonometry. You know that one of the most basic identities in trigonometry is sine squared plus cosine squared equals 1. So this cosine squared here, this cosine squared is 1 minus sine squared. And we already know that u is sine x. So let's rewrite the whole thing. So I have u to the 8. That is 1 minus u is sine x. So sine squared is u squared. And du. Now this integral becomes a very simple integral of polynomials, right? First, I distribute u to the 8 over the parentheses minus u to the 10 du. The rest is quite simple, right? Antiderivative of u to the 8 is u to the 9 over 9. Antiderivative of u to the 10 is u to the 11 over 11 plus c. Are we done? No, just one more step. Back substitution. U was what? When we use this substitution, u was sine of x. So back substitution gives me the final answer of sine to the power of 9 of x over 9 minus sine to the power of 11 of x over 11 plus c. So that's the final answer to this question. Let me do another example of case 1 that the power of sine is even and the power of cosine is odd. Before writing down the next example, do you think 0 is an even number or an odd number? Obviously, 0 is an even number, right? Because when we divide 0 by 2, the remainder is 0. So 0 is an even number. Having this in mind, let's look at the next example. And you will see that I mentioned the fact that 0 is an even number before the next example. In the next example, I don't see sine, just cosine cubed. And also let me make the coefficient of x 10x. As I mentioned earlier today, Uh, we are dealing with integrals of the form sine to some power of kx, cosine to power of n kx. So why this is falling under case one for for the integrals of this form? In fact, we don't see sine here as if it was a sine to the power of 0 of 10x. So we don't see sine. So as it's like sine to the power of 0, and 0 is an even number. So again, the power of sine is even and the power of cosine is odd. And that's why this is solved in the same way that, in a similar way that the previous example was solved. So please try this on your own and then watch my solution to make sure that uh, you haven't made any mistake. So you let u be sine of, in this case, not x because the angle is 10x. So sine of 10x. The derivative of u with respect to x is what? We have seen this kind of derivatives using the chain rule before. The derivative of sine is cosine, and the derivative of 10x is 10. So this is going to be 10 cosine of 10x using the chain rule. We have even seen this kind of examples in Calc 1 when you use the chain rule. So cross multiplication tells me that du equals 10 cosine of 10x dx. Similar to the previous example, I separate one copy of, so this was the substitution that we are going to use here. Let me keep it here. And so similar to the previous example, as I mentioned for case one, we separate one copy of cosine and write it next to dx. So this becomes cosine of 10x dx. From cosine cubed, I separated one copy of cosine. So cosine squared remains here. Here, du is 10 cosine 10x dx. So cosine 10x dx itself is what? If here I divide both sides by 10, I will have, dividing both sides by 10, du over 10 is cosine of 10x dx. So this part in the integral is just du over 10. How about cosine squared of 10x? Again, that's something that we know from trigonometry that for any angle, in this example, 10, the angle is 10x. Sine squared plus cosine squared is 1. Therefore, this is going to be what? 1 minus sine squared of the angle 10x. But remember that u is sine of 10x. So what's the conclusion here? The conclusion here is we have 1 minus u squared and then du over 10. That over 10 is like 1/10 comes out of the integral. And I have integral of 1 minus u squared du. 1/10 antiderivative of 1 is u. Antiderivative of u squared is u cubed over 3. And at the end, plus c. Just for the final answer, that I want to place it in this box, I can multiply 1/10 by these two terms, and back substitution u is what? Sine of 10x. So the final answer is going to be 1/10 sine of 10x minus 1 over 30th. Why 30th? 1/10 times 1/3 becomes 1/30th. Times u cubed. U is sine of 10x. So sine cubed of 10x plus c. So here that power of sine in the second term is 3. And that's the final answer. Okay, these two examples, they belong to case one, that power m is even and power n is odd. The power of sine is even and power of cosine is odd. Case two is kind of converse to case one. In case one, m, the power of sine, was even, and n, the power of cosine, was odd. Here we go the other way. M is an odd integer, and n is an even integer. You probably can guess that how the substitution will be different from case one. But the idea is very similar. So let's see an example here. Suppose I have, sometime in these integrals, we might have a number multiplied by this function. So let me put a 20 here. 20 times the sine cubed of 5x cosine to the 4 of 5x dx. Obviously, this is under case 2 because the power of sine, this m, is odd, and this n4 is an even number. So in this situation, in case 2, that power of sine is odd and power of cosine is even, we let u be cosine. And angle here is 5x, so we let u be cosine of 5x. So let u be cosine of 5x. Using the chain rule, the derivative of cosine of 5x is, the derivative of cosine is negative sine, and the derivative of 5x is 5. So the chain rule tells us that the derivative of u with respect to x is minus 5 sine of 5x. In other words, du is going to be minus 5 sine of 5x dx. When we do this example, we see that we will have sine of 5x dx. So let's also divide both sides by -5. So du over -5 is going to be sine of 5x dx. So this is the substitution that we use for this example. Now let's see what are we going to do here. U is cosine of 5x and du over -5 is sine of 5x dx. So this is in fact u to the 4. Now for sine cubed, I separate one copy of sine and write it next to dx. So what I'm going to have here is, by the way, that 20 is a constant. Let me bring it out of the integral. You know that when a constant is multiplied by the rest of the function, that constant, that constant factor can be pulled out. So I separate one sine, so sine squared remains, and write it next to the x. Let me make this a little bit more clear. So here, sine cubed was written as sine squared times sine x, sine of 5x. So the reason that we did that, because sine of 5x dx is in fact minus du over 5. I'm referring to this part. And I had cosine to the 4, which is u to the 4. The only part that needs to be written in terms of u is sine squared. That's not a big deal because we know that sine squared is 1 minus cosine squared. 1 minus cosine squared of 5x. And since u is cos squared, that part is just 1 minus u squared. So this is going to be 1 minus u squared. So let's see what we have so far. So far we have 20 times the integral of 1 minus u squared u to the 4 then du over -5 or minus du over 5. So minus 1/5 can be pulled out of the integral. So this is like a -5 here. It can be pulled out of the integral because it's like minus 1/5 has been multiplied by the rest of the function. So what are we going to do is here we'll have, let me continue on the next page. -20 over, that's -5. And for this part, if I distribute u to the 4 over the parentheses, u to the 4 times 1 minus u to the 4 times u squared, which gives me u to the 4 minus u to the 6 du. Okay, 20 over -5 is -4. Antiderivative of u to the 4 is u to the 5 over 5. Antiderivative of u to the 6 is u to the 7 over 7. And at the end, plus c. Let me distribute -4 over the parentheses, which makes -4/5. U to the power of 5. Back substitution. We replace back u by what? U is cosine of 5x, right? Cosine of cosine to the power of 5x. The angle was 5x. Then minus 4 times the next term. Minus 4 times minus 1/7 makes it a plus 4/7. And u is cosine of 5x. So u to the 7 is cosine to the 7 of 5x. And then plus c. And that will be the final answer. Okay, let's try another example that falls under case 2, and that example is the integral of sine to the 5 of 2x dx. Again, here the power of sine is 5, which is an odd number. And the power of cosine is, we don't see cosine, so the power of cosine is 0, and 0 is an even number. So m, the power of sine is 5, an odd number, and n, the power of cosine is 0, which is an even number. So similar to the last example, u is going to be cosine, so it is cosine of 2x. And the derivative of u with respect to x is minus 2 sine of 2x. In other words, du is minus 2 sine of 2x dx. But since at some point we need to replace sine of 2x dx by something in terms of du, let's divide both sides by negative 2. So I will have du over minus 2 is sine of 2x dx. So this is a substitution that we work with in this example. So I separate one copy of sine and write it next to dx. So it's going to be sine of 2x dx. So sine to the 5, the remaining power is going to be 4. Sine to the 4, 2x dx. So this part is obviously du over minus 2. And I need to use the substitution u is cosine of 2x. So I should be able to write sine to the power of 4 of 2x in terms of cosine. This is something that we know how to do this from trigonometry, something like from pre-calculus. We know that sine to the 4 is what? Sine to the 4 is sine squared squared. Sine to the 4 is sine squared squared, right? And sine squared is 1 minus cosine squared. The substitution tells us u is cosine of 2x. So how can I write this? So inside the parentheses, 1 minus cos squared of 2x. Excuse me. This is cos squared of 2x. So this is going to be 1 minus u squared, because u is cos of 2x. So 1 minus u squared, all to the power of 2. And then du over minus 2. Again, sine squared is, let me start from even one step before that. Sine to the 4 is sine squared, whole thing squared. And sine squared of 2x is 1 minus cosine squared of 2x. Knowing that cosine of 2x is u, so 1 minus cosine squared of 2x is 1 minus u squared, and all to the power of 2. So this power of 2 is the same as this power of 2. Now let's continue this on the next page. First of all, we pull out minus 1/2. That du over 2 is like minus 1/2. Then integral of 1 minus u squared du. From basic algebra, you know that how to expand 1 minus u squared all squared. You remember that a minus b all squared is a squared minus 2ab plus b squared. If I apply that formula from basic algebra, I'll get 1 squared, which is 1 minus 2 times 1 times u squared minus 2u squared plus u squared squared, which is u to the 4. Antiderivative of 1 is u minus 2 times antiderivative of u squared is u cubed over 3. So this is going to be 2/3 u cubed. And antiderivative of u to the 4 is u to the 5 over 5. And plus c. Just distribute that minus 1/2 over the parentheses and do the back substitution, knowing that u is cosine of 2x. So the final answer is going to be minus 1/2 cosine of 2x. Minus 1/2 times minus 2/3. Minus times minus plus. 1, 2 on the top, 1, 2 at the bottom. They cancel out. So I get 1/3 as the coefficient. U cubed, and u is cosine of 2x. So cosine cubed of 2x. Minus 1/2 times 1/5 gives me minus 1/10. And cosine to the 5 of 2x. And plus c. So that's the final answer to this example. Okay, now we go to case 3. Case 3 is the case that both m and n are odd numbers. So m is an odd integer and n is an odd integer. And because of that, we have the flexibility of letting u be sine or letting u be cosine. Either one is fine. We can choose either of those two. That sometimes one of them has less calculation than the other one, but in theory, both substitutions for case 3 work. So case 3 is more flexible than cases 1 and 2. Let's see, for example, sine to the power of 9 x cosine cubed x dx. I have 2 options to choose, u equals sine or u equals cosine. Either one is fine. In this example, the angle is x. So let me go with u equals the sine. And du over dx is cosine, or du is cos x dx. So since I let u be sine x and du is cos x dx, I need to separate one copy of cos and write it next to dx. So this is the substitution that we choose. Since I let u be sine x, this is going to be u to the 9. And so u to the 9. And cosine squared, or cosine cube is cosine squared times cosine x. The reason that we did so, because cos x dx is du. Cos x dx is du. And we should do something about cos squared, because we should write everything in terms of the new variable u. And I know that cos squared is 1 minus sine squared. And since u is sine x, this is going to be 1 minus u squared. So the integral becomes u to the 9 times 1 minus u squared du. Antiderivative, so before that, let me distribute u to the 9 over the parentheses. It's going to be u to the 9 minus u to the 11 du. Antiderivative of u to the 9 is u to the 10 over 10. Antiderivative of u to the 11 is u to the 12 over 12 plus c. Just one additional step, and that's a back substitution. U is sine x, so it is 1/10 sine to the power of 10 x, and minus 1/12 sine to the power of 12 of x plus c. The next example, oh, the next case, in fact, the next case is when there is no odd power for x, for sine or cosine. So sine and cosine have no odd power. In other words, both of them have even power. So case 4 is the case that m is even and n is even. Before doing any example, I need to remind you something from trigonometries from pre-calculus. So as a reminder, from pre-calculus or from trigonometry, sine squared of an angle of alpha, if I want to write this in terms of cosine of double angle, that's going to be 1 minus cosine of 2 times alpha over 2. I hope you remember this from pre-calculus or from any trigonometry course that you have taken before. And cosine squared of alpha is 1 plus cosine of 2 alpha over 2. The good thing about these two formulas are the left sides, which are of degree 2, are written in terms of trigonometric expressions of degree 1. Like for the first one, the power is 2, but the other side, there is no power of 2. That 2 to alpha is a coefficient of alpha, is not a power. The same thing with the other equation. So in fact, For doing examples of case 4, we'll use uh, these identities or these formulas from pre-calculus. Let's see an example. The integral of 10 sine squared of 6x. In this example, both powers of sine and cosine are even. Power of sine is 2, 2 is an even number. We don't see cosine, meaning that the power of cosine is 0, another even number. So the best way to do this is to use these identities that we just talked about. So first of all, 10 is a constant, comes out of the integral. Using the first identity, that sine squared is written as 1 minus cosine of double angle, can you write sine squared of 6x in terms of a cosine? Using that formula, it is 1 minus cosine of twice 6x. Twice 6x is what? Is 12x. And all over 2. So let's see what we have so far. 10 times the integral of 1 minus cosine of 12x all over 2 dx. That over 2 is like 1/2 coming out of the integral. So 10 over 2, which makes it a 5. Integral of 1 minus cosine of 12x dx. So 5 times antiderivative of 1 is x. Antiderivative of cosine of 12x. Do you remember antiderivative of cosine of kx? It's 1 over k sine of kx. So this is going to be 1/12 sine of 12x. And then plus c. Just distribute 5 over the parentheses. 5x minus 5 over 12 times sine of 12x plus c. So the answer is, let me make this 12 clear here. 5x minus 5 over 12 times sine of 12x plus c. Please try the next example on your own. This is very similar to these. The integral of cosine squared of 5x dx. This also falls under case 4. The power of sine is 0 even. Power of cosine is 2 also even. So we should use the identities that I reminded you here. Obviously, since here we deal with cosine squared, we use the second identity here. So which is the integral of 1 plus cosine of twice 5x is 10x all over 2. So 1 plus cosine of 10x all over 2. Over 2 is like a 1/2 coming out of the integral. and then the integral of 1 plus cosine of 10x dx. Antiderivative of 1 is x. Antiderivative of cosine of 10x. You remember that based on substitution, we had a formula that for antiderivative of cosine of kx is 1 over k sine of kx. So that's going to be 1/10 sine of 10x. And at the end, plus c. So let me just distribute 1/2 over the parentheses, and this will be our final answer.